Hello everyone, my name is Mohammad Rehan Ahmad. Today I'm presenting a paper on email security, exploring email auto configuration in the wild. So let's start with the abstract. This research investigates how modern email clients automatically configure themselves and how this convenience feature actually creates security vulnerabilities. So, in this talk, I will walk you through the research problem, the three-pass approach. I used the methodology, the findings, and what they mean for real-world security. So next we have introduction. To begin with, email auto configuration is a feature that allows email clients like Outlook, Thunderbird, or mobile apps to automatically detect the right server settings. Most users trust this process without thinking about it. But the paper shows that many providers implement this process in insecure ways. Misconfiguration, weak encryption, and unsafe fallback behaviors expose users to potential attacks such as credential theft and man in the middle intercepts. So, in simple terms, auto configuration is supposed to make life easier, but instead it opens door to major security risks. Uh, Here you can see the auto configuration security overview. This diagram shows what happens behind the scenes when an email app tries to set itself up automatically. The user simply types in their email address, but the client immediately sends multiple requests, usually DNS, HTTPS, or provider templates, to find the correct settings. If the responses are secure, the client uses proper encrypted settings and everything works safely. But the problem appears when the returned configuration is insecure. Many clients automatically accept weak TLS, expired certificates, or even plain text connection without showing any warning. This means attackers can intercept these insecure settings and perform man in the middle attacks or steal credentials. So this diagram highlights the main issue. Email clients trust whatever configuration they receive, and because the whole process is silent, users have no idea when their security has been downgraded. So next, this is the three-pass approach. So I use the three-pass reading method to understand the paper clearly. So in the first pass, I looked at the big picture. The problem was immediately clear. Email auto configuration is widely used but heavily understudied. The paper's goal is to evaluate the global security posture of the system. The contribution includes scanning auto configuration endpoints on a global scale and analyzing their security behaviors. So in the second pass, I focused on the methodology. The authors performed an internet-wide scan of auto-configuration endpoints. They analyzed TLS usage, insecure fallback behaviors, certificate validation, and compared providers. This pass helped me understand how the data was collected and tested. Next, we have the third pass. The third pass, I looked at the deep insights. More than 30% of providers still offer weak TLS settings. Many silently fall back to plain text connections without warning the user. So, several providers leak metadata about servers or internal systems, and authentication misconfigurations are very common. This deeper red showed how widespread and serious the vulnerabilities are. Then we have doing a literature survey. So when I received related work, I noticed that most previous research focused on email security problems like TLS downgrades, star TDLS, stripping, and DNS issues. However, almost no one studied the security auto configuration itself, which is the very first step in the email setup process. This paper fills the gap by highlighting the attackers can exploit insecure auto-config configuration before encryption or authentication even begins. Then we have this diagram of research methodology overview. This diagram represents the methodology of the study. The researchers started with the internet-wide scanning of auto-configuration endpoints. Then they classified the responses, evaluated TLS configurations, tested fallback behavior, and aggregated all the results. This structured methodology ensures that the findings are reliable and cover a very large number of providers globally. Next, we have experience. So, my reading experience was very positive. The paper is structured clearly, and the visualization made it easy to understand the severity of the issues. Real world examples from email providers made the results feel more practical instead of just theoretical. Overall, the paper gives a strong understanding of how something as small as a misconfigured auto configuration file can create a big security risk. Then we have related work. Previous studies have covered topics like TLS downgrade, attacks, DNS misconfigurations, and starty TLS stripping. What makes this paper unique is that it looks at the root cause behind many of these issues, which is insecure configuration instructions given to the client. So the authors are not just studying attacks; they are studying how bad defaults enable those attacks. So next, we have request. So in this section, the authors make a request to the community. They highlight that we need more standardization around auto configuration. Email providers should enforce strong TLS, remove insecure defaults, and verify server identity correctly. Developers should also validate the configuration files to avoid accidental exposure of sensitive information. Without these improvements, users will continue to be vulnerable. So next we have acknowledgement. The authors acknowledge the NDSS community, the contributors who helped collect data, and the organizations who supported responsible disclosure. This kind of research requires cooperation from many parties, and the acknowledgements reflect that. Then you go to the references section. Finally, the paper references past research on TLS misconfigurations, autoconfig standards, STAR TTLS research, and other security studies. These references help position the paper within the broader email security landscape. Then next we go to research problem summary. To summarize the research problem, auto configuration is meant to make email setup easy, but the lack of standardization and proper security checks makes it risky. Users unknowingly trust insecure server recommendations, and attackers can take advantage of this trust. Next, we have techniques and experiments. In the experiments, the researchers collected over 100,000 auto configuration responses. They tested TLS strength, measured how configurations behave during fallback scenarios, and compared providers across countries. This large data set allowed them to identify patterns that wouldn't be obvious in smaller studies. Then we have this diagram. uh, that summarizes how the researchers tested the security of email auto configuration in the real world. They began by collecting a huge data set, over 100,000 configuration responses from different providers around the world. Then they analyzed the encryption setup, which TLS versions were supported, whether certificates were valid, and how strong the security was. Next, they tested fallback behavior. For example, what happens if a server fails to offer secure settings? Many providers silently downgrade to weaker options, which creates vulnerabilities. After that, they compared the results by provider size and region to understand the patterns. So overall, the diagram shows the flow: collect, measure, test fallback, compare, identify vulnerabilities. Then we have the key findings and insights, in which the key insights are very important. A large number of providers still misconfigure auto configuration settings. This There is a huge variation in security practices between providers. Many systems still allow insecure fallback behavior, exposing users to downgrade attacks, and overall the ecosystem needs serious improvement. And finally, to conclude, this paper sheds light on security area that has been ignored for the long time. Auto configuration is incredibly convenient, but when implemented poorly, uh, it becomes a major security risk. This research not only exposes the problems, but also gives the community a directions for how to fix them. Thank you.